Hello everyone, welcome back to my channel. In this chapter, we'll be covering part 2 of class 12 chapter 2 Python revision tour 2. In the first part, we have already covered topics like strings, dictionary, list, tuples, and in this part, we'll be covering sorting techniques. So what is sorting? Sorting means arranging data in a particular order, ascending order or descending order. So ascending order means like if the numbers are present in ascending order, let's say if we have numbers like 2, 3, 5, 7. So this is ascending order. Okay. And if we have numbers like 10, 9, 8, 5, this is descending order. Sorting means we are arranging numbers in a particular order. Okay. So why do we do it? Because it helps in searching, organizing, and analyzing data efficiently. So, for example, we know that in order to do binary search, the list should be sorted. So that is why sorting is needed for many operations. The computer first it sorts the data and then only it performs next operation. Okay, so that is why we read about sorting techniques, how computer is trying to sort that particular data. Okay, so we know in this chapter we'll be covering two types of sorting techniques, bubble sort and insertion sort. First, we'll be looking at bubble sort. Bubble sort is the simplest sorting algorithm. Okay, so in bubble sort, it repeatedly compares two adjacent elements in a list and swaps them if they are in the wrong order. So let's say if we have a list of numbers, let's say we have 3, 5, 7. Okay, so these are the adjacent numbers. So what bubble sort does is it compares two adjacent numbers and swaps them, and it keeps doing this process until the list is sorted. And what happens is after first round, the largest element comes at the end. So after every cycle till the list till it is sorted, the it keeps bubbling up to the last, bubbling up at the end. Okay, so the largest element in the first cycle, largest element is comes at the list. In second largest comes at the second last position, and so on. So here we'll see how it works. So here we can see we have a list, and this is our list 5, 3, 8, 4, 2. Okay, so first what we'll do is we compare these two numbers. Okay, 5 and 3. Okay, so when we compare 5 and 3, since 5 is greater than 3 here, we will swap it. Okay, so what our list becomes 3, 5, 8, 4, 2, because we have swapped these two numbers. These two numbers have been swapped. Next, then now this is our list. Now this is our list. Next we have these two numbers 5 and 8. Okay, so we compare 5 and 8. So 5 and 8 are already at the correct position because 5 is smaller, 8 is larger, and these are at the correct position. So what we'll do, we will not swap it because they are at the correct position. So here, this is our final list 3, 5, 8, 4, 2. Okay, next we'll be comparing 8 and 4. Okay, so we compare 8 and 4, and since 8 is greater than 4, so again we will swap it. So we'll swap it and our list will become 3, 5, 4, 8. Okay, because we have swapped 4 and 8. Okay, next we'll be comparing 8 and 2. Since 8 is greater than 2, again we'll have to swap it. So after swapping, our list becomes 3, 5, 4, 8, 2, 8. Okay, so after the first cycle, see, this was our list. When we started, this was our list. Okay, so 3, 5, 3, 8, 4, 2, and 8 was the largest number. So after the first cycle, our list has become 3, 5, 4, 2, 8, and 8 has come at the correct position, which is at the last position of the list, right? So what we did was we compared the adjacent digits. Here we compared the adjacent digits. First we compared 3 and 5, and we swapped if they were not in the correct position. And if the adjacent digits were at the correct position, 5 and 8, there was no swapping required. So we did not swap it. Okay. Now, after the first cycle, this is our list 3, 5, 4, 2, 8. Now, what we'll do is, again, we will compare first 3 and 5. So, already 3 will compare 3 and 5. Since 3 and 5 are already at the correct position, so our list is 3, 5, 4, 8. Okay, then what we'll do? We will compare. Now, next we'll compare these two, 5 and 4. So, since 4 is smaller than 5, so we will swap it. Okay, and our list will become 3, 4, 5, 8. Okay, next, again, we will compare 5 and 2. Okay, so we will compare 5, 2, and since they are not at the correct position, we'll again swap. Our list becomes 3, 4, 5, 8. Okay, so now these two elements are at the correct position. Okay. We'll stop here. Okay, here, and this is our, after this second cycle, this is our final list. Okay, 3, 4, 2, 5, 8. So after the second cycle, this was our list 3, 4, 2, 5, 8. Again, first we will compare 3 and 4. Okay, at 3 and 4. Since 3 and 4 are at correct position, so we will not swap. Our list is 3, 4, 2, 5. Next we will compare 4 and 2. So since 2 is smaller than 4, so we will swap. So our list becomes 3, 2, 4, 5, 8. Next we will compare 4 and 5. Okay, 4 and 5. Since these are at the correct position, so our list stays 3, 2, 4, 5, 8. Okay, so here we'll see after this cycle, these three are sorted. Okay, next, so after the cycle, our list is 3, 2, 4, 5, 8. Okay, so after the third cycle, our list is 3, 2, 4, 5, 8. So then again, we'll be comparing these two elements 3 and 2. Take this element 3 and 2, and since 2 is smaller, so we will swap. So our list becomes 2, 4, 5, 8. Next, we will compare 3 and 4. It's correct. So our list is 2, 3, 4, 5, 8. Next, so we'll see all these last four digits have come at the correct position, and we'll see that this complete list 2, 3, 4, 5, 8 is now sorted, right? After enough passes, the list becomes 2, 3, 4, 5, 8. So this is how it works. The bubble sort works. We initially compare these adjacent numbers and we swap them if they are not at the correct position. And once our first cycle is done, the largest element comes at the end. And similarly, this cycle repeats until all the elements are sorted, right? So next, I'll just show you on PyCharm how it's done using Python code. So we'll write the code for bubble sort. So we'll start with a function. We'll call it bubble sort, and is length of our array for I in range n. We are taking a key swap and initially false for j range 0 to if array j is greater than array j 1, then we will be So in this code, what we are doing is we have created a function. Okay, we have taken this particular, we are passing this array. This array is like this numbers array. We are passing here inside this function. Here we are passing it. N is length of array. So here we are saying for I in range n. So range n means it will start from 0 and it will go up to n minus 1. Okay. So initially we have taken this case key swapped equals to false. Here now we inside this particular loop we have this another loop for j. Okay. So initially, so for j in range 0 to n minus I minus 1. Okay. I'll explain why we have written I minus 1 later. So initially what we are doing is for j in range 0 to n minus I minus 1, if array j is greater than array j plus 1. So if these two adjacent values, okay, we are comparing these two adjacent values. If they are greater than, if this array j is greater than array j plus 1, so we were swapping it. And we have called this key swapped equals to true. I'll explain this code with the help of debugging, then it will become clear. So initially what we are doing is we have these numbers, this is the list of numbers, okay, and we are passing this array, this particular array numbers inside this function bubble sort. Here array is 5 4 1 6 2. Okay, so n is 5, 1 2 3 4 5. So the length of array is 5, n is 5. Now initially when we are starting, we are saying I, the outer loop I, which will go from 0 till 4. Initially we have taken a key swapped equals to false. Now we have created this another loop j. Okay, j will go from 0 to n minus I minus 1. Right now value of n is 5, value of I is 0. So this range will grow from 0 to 4. Okay, so what we are doing is array j. So array j is initial, right now the value of j is 0. So array 0 is 5 and array j plus 1 is array 1. So array 1 is 4. Okay, so we are comparing array j is this, array j plus 1 is 4. So we are right now first we will comparing 5 and 4. Okay, since 5 is greater than 4, so we'll have to swap it. So we are swapping it. Okay, so here array j, we are putting array j plus 1 value in array j and we are putting array j value in array j plus 1. Okay, so here this line we are swapping it. Okay, now this swapped key becomes true. Okay, so this swapped key becomes true. Again it goes inside the room, inside the loop. So the value of I is 1. So our first sorting is done. See, 4 has come here and 5 has come here. Right? Now next what we'll be comparing? We'll be comparing 5 and 1. Right? Now initially the value of j is 1 and this was array j plus 1. So we'll be comparing 5 and 1. We are comparing 5 and 1. Since 5 is greater than 1, we'll have to again swap it. So here in this line number 9, we are swapping it. Array j, we are putting array j plus 1 value in array j and array. Okay, so at the first position we'll be putting 1 and at the second position here at second index we'll be putting 5. So we'll again swap it. It says swap is equals to true. Again we'll go inside the loop. This loop will continue for 0 1 2 3. Okay, now j becomes 2. So when j becomes 2, we'll be comparing 5 and 6. 5 and 6. Now 5 and 6, since these are already sorted, if 5 is smaller than 6, 6 is at its correct position, so no swapping is required, right? Since no swapping, so it again value of j will increment, j becomes 3, right? Because this loop is supposed to go from 0 till 3. J becomes 3. So 1, 2, 3. So this is the last time this inside loop is running. Now j has become 3. Now we will be looking at element 6 and 2. 6 and 2, obviously we will be sorting them again. So here swap will happen, 2 will come here, 6 will come here, right? Now swapped is true. Next, now j becomes 4, so it comes out of the loop, right? Now it will check whether if not swapped. So swapped is true. Swap, because swapping happened, so swap key has turned true. Okay, so not go here. Okay, so here I've made this mistake. Return array will come here. Okay, because right now only first cycle is done. Okay, after first cycle, array becomes 4, 1, 5, 2, 6, and the largest element 6 has come at the end, right? So we'll be running. This will continue till all the elements are sorted. Okay, so I'll just have to debug it once again. And okay, so now earlier I was 0. Okay, I will become 1. Again, swapped key was false initially. Now initially again we'll start with j from 0 to n minus I minus 1. So n is 5, 5 minus 4, 5, n is 5, 5 minus I is 1, minus 1. So here it will run for 5 minus 2, that is 3 times. 5 minus 2 is 3, from 0 to 3. So it will run from, and since 0, 1, 2. I hope this is clear. Since we know this last number, this range is not inclusive. So here we are saying j will run from 0 to n minus I minus 1. I value of I is 1, so it will run from n minus 2. N is 5, 5 minus 2 is 3. 0 and 3. Okay, and since so it will run from 0, 1, 2. Right? Okay. So initially j is 0. So if j is 0, we'll start again from here. We will be comparing this 4 and 1. So we see if array j is greater than array j plus 1. So we'll be comparing 4 and 1. So again we'll be, since these are not at correct place, so we will be swapping them. Now swapped key becomes true. Now j will become 1. Okay, so we will be comparing 4 and 5. Since 4 and 5 are at correct position, so no swapping will happen. It will again we'll increment j. Now j becomes 2. Now we'll be looking at 5 and 2. Since 5 and 2 require swapping, so we will swap it. Okay, so here, so now 2 and 5 are swapped, right? Now, and value of j is already 2. Now, since we can only go from 0, 1, 2, j can only go from 0, 1, 2, it comes out of the loop. And again, we increment I. Now, I becomes 2. So, again, swapped is false. We'll again go inside this j. J is 0. So, initially we'll compare 1 and 4. We'll be comparing 1 and 4. Since 1 and 4 are correct position, so no swapping will happen. Now, we'll increment j. J becomes 1. Okay, j becomes 1. We'll be comparing 4 and 2. Since 4 and 2 are not at correct position, we will swap them. Will come here, 4 will come here. And here, see, the value of I is 2. So n minus 2 minus 1. So n minus 3. 5 minus 3 is 2. Loop will go from 0 to 1. Here it will go from n if n is 5 and 5 minus 2 minus 1. Okay, so it becomes 5 minus 3, which is 2. So here this value becomes 2. So it will go from, loop will go from 0 and 1. So for 0 and 1. Now 1. So now swapped is true. Again it will come out because it can only go run for 0 and 1. Okay. Now again I becomes 3. Swap becomes false. Now value of j is again 0. So we'll be comparing 1 and 2. And since value of I is 3 now, now value of I is 3. 5 minus 3 minus 1, 5 minus 4, which is 1. Okay. So here the loop will only go for 0. This, so only for j equals to 0 the loop will run. We'll compare 1 and 2. And since they are both at correct position, so no swapping happens. Now j becomes, obviously we cannot increment j because j runs on for one time. So here we now return the array, and our array has become 1, 2, 4, 5, 6, which is, that means our array is sorted. Okay, so I hope this is clear. If it is a bit complicated, then I suggest you to debug it on your computer and see how it's done. What we are doing is, we have this outer loop I, that is for, because we want to run for all, for we want it to run for multiple cycles till it is sorted, and inside we are swapping we are looking at every adjacent digit and swapping it for, and for that we have this particular loop here, this step, this, here we are, the swapping is taking. And see, for the first time we are looking at all adjacent numbers and swapping it, and here we have said 0 to n minus 0 n minus I minus 1, because after first cycle this last element is already at the correct position. Okay, then after second cycle, these two are already at the correct position, and after third cycle these three are already at the correct position. Okay, so we are not running always running till the end. We are running from, initially we are running from here to here, then we are running, our loop is running from here to here, then our loop is running from here to here. Okay, that is why we have said n minus I minus 1, because if we remove this I, then our loop will, for every time it will run from 0 to n minus 1. And since after every cycle we are already, this last element is at correct position, then these two elements are at correct position, then these three elements are at correct position, we do not want it to run till the end for every cycle. We want it to run for one less element after every cycle. That is why we have written n minus I minus 1. Hope this thing is clear. If it is not clear, then please let me know in the comments. I'll explain again. We'll look at the time complexity. Time complexity measures how many number of operation grows as the size of input increases. Bubble sort, we mostly count comparisons and swaps. For the first case, this big O of n square. Okay, so why is it big O of n square? Because when the array is in reverse order, completely, if the array is in reverse order, completely unsorted, so in the first pass the algorithm compares n minus 1 elements. The second part, it compares n minus 2 elements, right? So here, so for the first cycle, comparing n minus 1 element. In the second cycle, comparing n minus 2 elements. Okay, so on. In the last cycle it will compare one element. Okay, so if we count the total number of comparisons, these are n minus 1 plus n minus 2 plus n minus 2. So here we solve it, it becomes n minus 1 by 2. So here if we compute it, it will this big O of n square. Okay, I hope this thing is clear. We already saw that for the first cycle, it was making comparisons. How many comparisons it was making? It was making n minus 1 comparison. For the second cycle, since last element was already sorted, it was making n minus 2 comparison. Okay. Then it was making, last two elements were already sorted, so it was making n minus 3 comparisons. Till at the end, it was making only one comparison. Okay. So here, so when we calculated, it becomes n minus 1 by 2. When we do it, we n square minus n by 2. So it gives us big O of n square computations. And this was the case when this was the worst case, when this was completely unsorted. For the best case, we have big O of n comparison. Let's say if our array is already sorted, the bubble sort will still go through one full cycle to pass to check elements. We have already seen it will go through each element once, and it will check whether that swapped key becomes true or not. So if the list is already sorted, so swapping will not happen. So swapped key will not become true, right? So it will know that now no comparison, no swapping was required. So after that one cycle only, we will know that swapping is done. So for that case, we have big of n comparisons. I'll just show you on PyCharm. So let's say if I have a list 1, 2, 3, 4, 5, 7. This is already a sorted list. So here, if I right click and debug it, okay, so initially this is my list. Now n is length of array, which is 5. Then we'll get inside this outer loop I value of I becomes 0. Swapped key is false right now. Now it will go inside this loop j will go on for initially for I equals to 0, j will go on for 0, j will go on for, and n is 5 minus I is right now 0 minus 1, so it will go on for 0 to 4, so it will go on from 0 to 1, 3, right? So right now value of j is 0. Checks array of j and array of j plus 1 and 2 it will check. Since no swapping is required, a value of j becomes 1. Again it will check 2 and 4. No swapping is required, so value of I becomes 2. Again it will check 4 and 5. No swapping is required, I becomes 3. It will check 5 and 7. No swapping is required, so this swapped is still false. So here will come out of the loop. Alright, that is why in just one single cycle we saw that since no swapping was required, so this means that our list is already sorted and we will only do n number of computations. For this, n square is not big O, n square computations are not required. Big O of n is the only n number of computations are required. That is why the time complexity is big O of n. And initially for the worst case, the time complexity was big O of n square. Next is average case. For average case also the time complexity is big O of n square. For average case, the array elements are randomly arranged. So about half the elements will need to be swapped. The number of comparisons still stays about the same as the worst case, is n square by 2, and so the average complexity is big O of n square. And for this, the space complexity is big O of 1, because bubble sort is in place, meaning it sorts the array without needing extra memory, right? So only a few variables are used for swapping.
Okay, so the next topic is insertion sort. So insertion sort is a simple sorting algorithm that builds the final sorted list one element at a time. So insertion sort is also used for sorting, and we sort it in either in ascending order or descending order. And this is similar to sorting cards in our hand. So for example, if we say we have a deck of cards and we take 5 cards out of from that deck of cards, and let's say if we pick one single card from those 5 cards, and we'll see where that single card should be placed, like what are the cards that are greater than that card and what are the cards that are smaller than card, and we'll place that single card accordingly. So similarly, then we take another card and then we place it at the correct position, and we keep repeating it till all the cards are sorted. Okay, so this is how insertion sort works. See, so this is the example here. So let's say we have these 4 cards. So we have a club of 7, a heart of 3, diamond of 5, and spade of 2. So we have a club of 7, heart of 3, diamond of 5, and a club of 2. Okay, so these are our 4 cards. Now we'll start with 7. So single card 7 is already sorted. Next we say we take 3. Now 3 is smaller than this card 7. So we place 3 before 7. So 3 will come here, 7 will come here. Okay, so this much part is sorted. Next we take 5. Okay, now we see that 5 is smaller than 7 but is greater than 3. So it should come in between 3 and 7. Okay, so we put 5 in between. So here 3, 5, 7. Next we see 2. Okay, so now 2 is smaller than 7, it is smaller than 5, and it is smaller than 3. So we place 2 here. So this is our sorted list 2, 3, 5, 7, and this is the final order. 2, 3, 5, 7 is the final order, and this is how we sort cards. Okay, this is how insertion sort works.
So we'll see how it works, how insertion sort. So let's say we have array. Our array has these 4 numbers 7, 3, 5, and 2. Okay. Now we'll start with the first element 7. Single element is always sorted. Okay. So 7, we have started with 7, and single element 7 is always sorted. Next, what we'll do is, this is our sorted element 7. This is our unsorted remaining list 3, 5, and 2. Now what we'll do is, we'll compare 3 and 7. Okay, when we'll compare 3 and 7, since 3 is smaller than 7, okay, is smaller, so we place it before 7. So here what we are doing is, we have placed before 7. This is our sorted part. Okay, which part is sorted, and this is our unsorted part. The remaining element is 5 and 2. Next, what we'll do is, we'll compare 5 with these two elements 3 and 7. We'll see that 5 is smaller than 7 but is greater than 3. So what we'll do, we'll put it in between 3 and 7. Okay, we put it here in between 3 and 7. So it becomes 3, 5, 7, and here the unsorted part is 2. This part is sorted. Next, now 2 is remaining. Okay, we'll compare 2. First what we'll do is, first we'll compare 2 with 7. So we insert it before 7. Next we compare it with 5, and we insert it before 5. Next we compare it with 3, and we insert it before 3. So we have put 2 before 3, 5, and 7. And this is our final sorted array. So I hope this is understood how insertion sort works. Here I'll write the code for insertion sort in Python, and then I'll explain how it is working. Okay. First we'll create a function called insertion sort, and we'll pass array here. Okay, I'll show you. The array will be passed this. Okay, and we'll print sort. L will be returning this sorted array, and that will be printing here. So first we'll calculate the length of array. Now we'll say for I in range to, we'll say key is equals to array I. Initially we are saving this key array I, and here take current. Now j is equals to -1 while j is greater than equal to 0 and array j is greater than key. Array j plus 1 is equal to, so what we are doing is shift element to the j is j equals to key element at correct position and will return. So I'll just debug it here and then I'll explain you. Okay, you'll right click, debug insertion sort. Okay, so here initially our array is 8 2 1 4 3 0. Okay, so this is our array. So first what is happening is we are calculating the length of array. What is the length? 1 2 3 4 5 6. Then what we are doing is we are taking I. We have two loops here. Okay, this is the outer loop I. So I will go from 1 to n. So value of n is 6. So I will go for 1 2 3 4 5. Okay, here I will go for 1 2 3 4 5. Why? Because in last value is not inclusive. So right now the value of I is 1. When the value of I is 1, array of 1. So the key is array of 1. And what is the value of array of 1? Array of 1 is 2. So what is the value of key? Value of key is 2. Okay, this is array of 0. Array of 0 is 8. Array of 1 is 2. So first what we have taken this key array of 1. Okay, next we take value of j, and j is I minus 1. Value of I is 1, so value of j is 0. Okay, for this case value of j is 0. Okay, so we have taken this loop while j is greater than equal to 0 and array of j greater than key. So j is greater than equal to 0. Value of j is 0 and array of j is array of 0. Right? Array of 0. This value of j is 0. So array of j is 8. So we have here let's array of j. Right now array of j is 8. Okay, array of j is 8 and value of key is 2. So 8 is greater than 2. Right? 8 is greater than 2. This is true. And j is equal to 0. This is true. So both these are true because we have taken and. Both these conditions should be true. So while this is true, what we'll do is we will put array of j value. So what is the value of array of j? Array of j is 8. We'll put this value array of j in array of j plus 1. So value of j is 0. So here 0 plus 1 array of 1. So we are putting 8 in array of 1. So what happens here is our array of 1 becomes 8. Okay. Now what we are doing is we are decrementing j. Now j becomes minus 1. I'll just show you here. Here what we are doing is array of j plus 1. That means array of 1. Here this value has become 8. Right? This value has become 8. Now we are decrementing j. When we decrement j, it comes out of the loop. Because now j should be greater than equal to 0 and value of j becomes minus 1, which this condition is not true. So it comes out of the loop. Now what we'll do is, now since we have put 8 here, what we need to do? We need to put that initial value key 2 here. Right? So what we'll do? We'll put key at position. Now value of j has become minus 1. So minus 1 plus 1. So array of 0. This is array of 0. Array of 0, what we will put this value 2 at array of 0. Okay. right? So our first swapping is done. Okay, so this first cycle, after first cycle, we get 2 at 2 here and 8 here. Next, what will happen is, now I becomes 2. I becomes 2. So what will be our key? Initially we had started with I equals to 1, so this was our key. We were comparing this. Now this is our key. We will be comparing this 1. Okay, we'll be comparing this 1, and we will be comparing 1 with these two elements. Now this much part is sorted. 2 and 8 is sorted. This much part is not sorted. 1 4 3 0 is not sorted. We will be again we will be putting 1 at the correct position here. Okay, so now value of I becomes 2. Here I becomes 0 1 2, so I is 2, and key is array of I is 1, this value 1. Okay, now value of j becomes I minus 1, so value of j can becomes 1. So for this case, how many times this loop will go on? While j is greater than 0, greater than equal to 0. For j equals to 1, it will go on, and for j equals to 0, it will go on. 2 times this loop will go on. Initially, loop only ran for just j equals to 0. Then j became minus 1, so it came out. Right now, loop will go on for j equals to 1, and then it will decrement, and then it will become j equals to 0. So j is greater than equal to 0. Yeah, value of j is 1, which is greater than equal to 0. What is the value of array of j? The value of j right now is 1. Array of 1 is 8. Array of 1 is 8. And what is the value of key? Key is 1. Array of j is 8, is 1. We are comparing these two elements. So obviously this array of j, this value 8, since it is greater than 1, what we'll do? We'll shift the elements. So we'll put array j plus 1, so array 2, and what we'll put here? We'll put array of j, array of 1. So array of 1 is 8. 8 will put at this position, array 2. Show you, see. After this, what will happen is, we have put 8 at this position at array 2. Here, this is what? This is array 2. And it is asking to put array 1, which is 8, value 8, which is value 8 at this position, array 2. Then we'll decrement j minus 1. Now j becomes 0. Again, since j is 0, and array of 0. Array of 0 is 2. And value of key was 1. We have saved the value of key. Value of key was 1. So we will be comparing 2 and 1. We will compare 2 and 1. Again, when we compared, so this array of j, 2. Value of 2 was greater than 1, was greater than value of key, which is 1, right? So here again we'll be shifting. We will put array of j plus 1. J is 0. 0 plus 1, 1. Array of 1, that is this position. Here we will put, what value we will put here? Array of j. And array of j is 2. Because array of j is 0. Here array of 0. Array of 0 is 2. Again, what we'll do? We will put at this position here, at this position where 8 is there, we will put 2. Okay. Now these two we have already shifted. Next we will decrement j. Now j becomes minus 1, so it will come out of the loop. And now we already had key saved. Key is 1. Where we will put it? We'll put it at j becomes minus 1, so minus 1 and 1. Array of 0. At this position, array of 0, we will put key 1. So here this becomes 1 2 8. Now this much part 1 to 8, this much part is sorted. And what is not sorted? This much part, 4 3 0. So next our current element will become 4. Here we will see value of I is now 3. Value of I is now 3, 0 1 2 3. Value of I will become 3, and the correct current element, array of 3. This array of 3? Array of 3 is 4. E will become array of 3, that is 4. Now we will be comparing 4 with all the previous elements, 1 2 and 8. Okay. Now the value, since value of I is 3, value of j will become 2. So for how many times this loop will run? It will run for 0, 1 and 2. And as soon as it becomes -1, it will come out. It will run for 0, 1 and 2. Initially right now value of j is 2. 2 is greater than equal to 0, true. And array of j, that is array of 2, 0, 1, 2. Array of 2 is 8. Array of 2 is 8. And we are comparing it with key. And our key is 4. We are comparing 8, 4. And since 8 is greater than 4, also true. So we will get inside. And so now since this is 8 is greater than 4, so we'll have to shift it. 8 is greater than 4, so we'll be shifting it. So what we'll do, we will put at this position j plus 1. J is 2. 2 plus 1 at this position, we will put this value, array of j. Array of j is array of 2, that is 8. This value 8 we will put at this position. And we have already saved that value key. That value key is saved with us. Now we will decrement j. Now this is true, 1 is greater than 0. And array of j, array of 1. What is array of 1? 0, 1, 2. We'll compare 2 and 4. Now when we compare 2 and 4, 2, array of 2 is greater than key? No, it is not greater than key. Right? 2 is not greater than 4. So this loop, we will not go inside this loop. Okay. So that means that this much part is smaller than 4. Right? So where we'll put this value key? We will put this value key at this position. Right? So the value of j is 1. J plus 1. 1 plus 1 is 2. Array of 2. 0, 1, 2. This array of 2, at this position, array of 2, we will put key 4. We have put here. Put it here. Now this much part is sorted. 1, 2, 4, 8. This much part is sorted. Now I will become 4. Now I becomes 4. Then the current element becomes 3. Now what we'll do is, first we'll compare this key with this value. We'll decrement I. I becomes 3. 0, 1, 2, 3. We'll be comparing this element 8 and our key. Since 8 is greater than 3, this array j is, value of array j is 8. 8 is greater than this key 3, and j, value of j is 3 is greater than equal to 0. This loop is true. So what we'll do is, we'll shift the element. Okay. So what we'll do is, we'll put array j plus 1. J is 3 plus 1, 4. At this position 0, 1, 2, 4. Array 4. At this position, we will put 8. Here. So we have put 8 at this position. Now, we'll decrement j. We have decrement j. Now, value of j is 2. Now, array of 2, what is the value of array of 2? 0, 1, 2. This much, 4. Now, 4 is greater than 3? Yes, 4 is greater than. Again, we'll go inside the loop and we will shift and we will put this 4 at this position. Okay, this 4 will come at this position. So, the value of j is 2. 2 plus 1, 3. 0, 1, 2, 3. At this array 3, we will put this position array of j. Here, 4 will come here. 4 has come here. Now, again we'll decrement j. Now, value of j has become 1. 0, 1, 2. We'll compare 2 and 3. So, 2 and 3, 2 is already smaller than 3. So, since array of j, which is 2, is not greater than 3, again, we will not get inside this loop. We will come out of this loop and it will come here. Now, what was the value of j? 1. So, j plus 1, 1 plus 1, 2, array of 2. At this position, array of 2 will insert our value key. Now, this much part is sorted. 1, 2, 3, 4, 8. Last is 0. So, I becomes 5. So, I becomes 5 and what is the value at index 5? E becomes 0. Again, we'll decrement j. J will become 4. Loop will go on for 0, 1, 2, 3 and 4. Initially, right now, value of j is 4. Then we'll compare array of j. Now, array of j, what is the array of j? Array of 4, 8. This array of j is, value is 8. 8 is greater than key. We'll get inside this loop and we'll shift the element. So here j was 4 plus 1 5. At the location array of 5, we will put this value 8. Okay. Now we'll decrement j. We'll decrement j. Again, what we'll compare? J is 3. So array of 3 is 4. 4 is greater than 0. 4 is greater than 0. True. Again, we'll shift the element. So j plus 1 plus 1 4. Location array of 4. We'll put value array of j. That was 4. So we will put here 4. 4 will come here. Next, we'll again decrement j. Now we'll compare array of j. Array of j is array of j is 2. 0, 1, 2. So 3. We'll compare 3 with 0. So 3 is greater than 0. Again, we'll have to shift. Now again, we'll decrement j. We have decremented j. Now j has become 1. So array of 1 is who is greater than 0. We will put it at j plus 1 location, that is here at this position. Will come here. Now again we'll decrement j. Now array of j 1. 1 is greater than 0. Again we'll shift. So 1 will come here at this position. 1 has come here. Next, then we decrement j. Now j becomes minus 1. We come out of this loop. Once we come out of this loop, so here we will put j is minus 1. Minus 1 plus at array 0. At array 0, we will put our key. The key was 0. And since it will only run till I equals to 5, so we return the array and our final array is 0, 1, 2, 3, 4, 8. This is our final array. Okay, so I hope that here we are taking single element that becomes the current element, then we are comparing that key with all the previous elements. Accordingly, we are arranging that. Hope this is clear. If it is a bit complicated, then I would ask you to again debug it on your computer. So next is time and space complexity of insertion sort. So we see that for the best case, for the list that is already sorted, the time complexity is big O of n. Only one comparison per element is required. So let's say if we have a list 1, 2, 4, 5. So here we see that this list is already sorted. So each new element is compared only once and no shifting is needed. The time complexity here is big O of n, since each element is already in its correct position. Each element will be comparing only once and no shifting is taking place. Now for the first case is the time complexity big O of n square. So if we have a list like 5, 4, 2, 0. Okay. So here each element is compared with its previous element and maximum shifting for each element we'll have to shift. Okay. So for this each element goes to the beginning every time. Right. So here the time complexity is big O of n square because each element has to be compared with all the previous ones. For the average case, the element is compared with half of the sorted list, and for that also time complexity is big O of n square. And for the space complexity is big O of 1. Okay, there's no extra memory is needed, only few variables. So the space complexity for insertion sort is big O of 1. So this concludes our chapter 2, part 2, and we have completed both bubble sort and insertion. And chapter 2 is also done. So I hope all the topics that were explained here are clear. And if you find any difficulty in any topic, or if you want me to explain any topic again, to let me know in the comments. Thank you. Happy learning.